Let's review Topaz Lab software on Apple M3 laptop. This is ArtIsRight. A big thank you and welcome to those of you who have already subscribed. If you're new, please consider doing so. One thing that all of you can definitely help me out with is to tap on that like button. This way YouTube algorithm will push this video to an even larger audience. As usual, I'll be sharing lots of information. Please pause the video so you can analyze the result yourself, in addition to the analysis I'll be sharing with you. Timestamp will be in the description. If you find the information that I'm sharing with you helpful, please consider supporting the channel. Leave a link to my tip jar in the description. YouTube Super Thanks works as well. And something new that I'm trying out is a membership to my channel, which will give you priority replies on any of the comments and questions that you ask on any videos. And regardless of what you do, I appreciate all of you joining me on this journey. With that said, we are going to take a look at 5 primary test system. All these are going to be a variety of M3 SoCs, starting with just the regular M3. And then we're going to take a look at the M3 Pro Base, M3 Pro Top, M3 Max Base, and M3 Max Top. Now, when I'm talking about base versus top, I'm really just talking about the silicon, because there's a base silicon and there's an upgraded silicon. That's what I'm really referring to. I'm not talking about the RAM on the system or the SSD by any means. I'm trying to keep these machines as stock as much as possible. All right, with that said, we are going to take a look at some additional test system as well. M2 Pro, M1 Max, and also M2 Max in addition to the M1, M2, and also obviously, the Mac Studio with the Ultra, M1 and M2 are going to be part of this lineup too. Now, I have already made extensive guides and comparison review for most of these computers. I'll leave links to them in the description. I highly recommend you check that out. Everything has been retested on all of these machines. Clean install Sonoma running either 14.1 or 14.1.1, and these are the latest software downloaded from Topaz website. Here, how you can read the specs on all these computers. This is the cheat sheet, and these are all the abbreviation code. If you need to come back to this, I will put a timestamp back to this in the description as well. As far as test file goes, we are going to take a look at 2 different images. And for these, we're also going to take a look at one that is a JPEG, uncompressed, obviously, at 100%, and also an NEF. This is a Nikon RAW file, and this is 46.1 megabytes. So the size is there, and also the megapixel of the file is there as well. This way you can get an idea. Additionally, we're also going to be working with 192 megapixel panorama. This is a JPEG that is 128 megabytes, and a DNG file that is 687 megabytes, just about there. And these are pretty much the megapixel for the camera itself, not the actual file. The actual file is 192. And the resolution. All right, so a couple things to clarify before we get into look at the result is a setting that I've used. For all these machines, I've gone in and specified the AI processor and the allowed memory consumption set to high. So this has been done throughout all of the Sharpen, Denoise AI, and also Giga AI as well. So all of those have been done that way. As far as Topaz Video AI, I have gone in and target the max amount of processes, which is 4. And interestingly enough, on the base machine, there's 4. On the top spec machine, where there are many more cores, there are still only 4 top processes. And I have a couple of thoughts about this as well. One thing that I will share with you is something that I've shared before, and that is Topaz software does not scale well at all. You can try to do a batch processing, but what that really means is it's still going to go through your files in a very serial fashion. Finish one file up first, then start the next one throughout the whole process. Yes, it is using the neural engine based on the model that they have come up with to enhance the picture, which is great. However, the process of really going through hundreds of files, if not more, it's not necessarily the most fastest you can actually find. The other thing too is that on Giga AI, I'm just going to point this out. I cannot get the program to show me the timing that it takes to process a file, whereas in Sharpen AI and Denoise AI, it does show me that. So if you know how to do that, do let me know in the comments below. I'm curious about that. As far as the video AI goes, all of those are just timing, but we're going to talk a little bit more about that as well. Let's start with Sharpen AI. For this, we'll be taking a look at all the M3 in comparison, both NEF and JPEG, and then afterwards I'm going to break this down between NEF only, JPEG only, and add all the other machines in the lineup. So you can also pause and see how the other M series chip are really comparing to the M3 generation. All right, interestingly enough, when we take a look at just the M3, from the base one to the top M3 Max, we have a time variation of around 3 seconds. Now, this 3 seconds, if you're working with 1, maybe 10 images, it's not a big deal. If you're working with hundreds, it may start to make an impact. If you're working with 1,000, yes, this time is really going to start to compound. So these are things to really think about in your workflow. Now, the one thing that I do want to point out though is between the top M3 Max versus the base M3 Max SoC, and we're just talking about the silicon here. This time variation of 1 second is around $500 in price variation. Is this really worth it or not? This is a question that you really have to answer yourself. However, I will also point out that the M3 Max base SoC in both the 16 and 14-inch model is one of the best SoC this time around, and it will give you the best bang for the buck if you want the Max SoC. Similar story can be seen in the M3 Pro. 1 second apart, this attributes to around $200 in price variation for the SoC, and I would argue that the base 14-inch MacBook Pro is an extremely great value, especially if you go in and upgrade that to 36 gigabytes of memory. I think that's going to be a really clear winner machine for the price that you pay and the performance that you're getting. Now, taking a look at the JPEG, you can see that there's some anomaly in the M3 Pro right there, which is why it's performing a little bit longer, but the timing, you get the chance to see there is only 1 or 2 seconds apart, really not that big of a deal at all. This is Sharpen AI for the Aurora with all the machine added, and this is the raw file. When we take a look at this, a couple of things that I want to point out is that the top M3 Max is performing dead equal to the M2 Ultra, with the M1 Ultra coming just right behind. But if we take a look at the time variation between all of these, we're only talking about just a second or two apart. It's really not that big of a deal. A few things though that I do want to point out is that the M1 generation in the Max is really performing just fine. However, just the regular M1 itself is starting to really lag behind running on macOS Sonoma and all of these. So if you have just the regular M1 machine, whether in a laptop or a desktop format, it may be time to consider upgrading, because you are going to see a significant improvement when you really get into the M3 generation or the more powerful even M1 chip such as the M1 Ultra. Here's the result for the JPEG comparing all of the machine in a lineup. You can see that very similarly to the other one, they are only just about a second apart between all of these machines. Not that big of a difference at all when you really take a look at this. However, just the regular, for instance, M1, M2, they're not really performing that well anymore with the current OS and the software running it. So these are things to definitely think about when you're looking at this. All right, so this is Sharpen AI for the panorama image, and for this we're taking a look at DNG and JPEG again. This is taking a little bit more time because obviously it is a larger file, but the way how these are really scaling, remember, this is 500 for around 3 seconds. This is still 200 for 1 second apart. You start to get an idea. Now, does the RAM really play a role in Sharpen AI? To an extent, but you can see that it's really playing a role, but once you really get to like a certain plateau, it's really increasing the gain very minimally and marginally for Topaz software. So I would really configure the way how you're using your computer based on the primary photo editing app they're using, not so much based on Topaz software. This is really more of an educational thing to see how the machine performs. This is pretty much how it is performing in JPEG, very similarly to the way how it's performing in DNG, just a slight touch faster. Here it is in just the DNG format in Sharpen AI. You can see how they perform apart there. Very similarly, M2 Ultra with more memory is performing ahead, and this has 128 gigabytes, so it is a lot more memory. That is definitely helping. But a couple of things to notice about the M2 Ultra as well is that it also has more NPU. That is a neural processing engine. The way how Topaz app, I have been observing this go through the neural processing engine, is that it's using the CPU core to pretty much unpack the image and sending all the data primarily to the NPU to do all the AI processing. Then afterwards, it gets back to the CPU for the repackaging of the image together again. And I think this is like a couple of things are really attributing. The number of cores in the CPU itself is not really doing much. NPU is probably doing a little bit more in this regard. And the other thing that we're probably seeing the advantage of this will probably be the fact that it has more memory in the system. However, this can also not be true as well, because 64 is supposed to perform better than 48, yet it is around 1 second behind. And you start to see the number there, 36 gigabytes on this one's performing better than 64. So this is disproving the idea for having more RAM is faster, but it's also pointing out as well that the number of NPUs in the system is really playing a role here. So a lot of factors are at play when we start to take a look at Topaz software. This is JPEG. And you can see the time spread between all of them very similarly to the other. Now let's take a look at Denoise AI. For the Aurora, both NEF and JPEG, the NEF are pretty much all the same for the Pro and the Max, with the M3 trailing a little bit. When it comes to the JPEG, the two Max are performing the same and the two Pro are performing identically the same. And between the Pro and the Max, they are just 1 second apart, with the M3 trailing behind. As you're going to start to see in many of these charts as well, a trend is starting to develop. The regular consumer SoC, the M3, M2s, they're holding on just fine in the current generation right now, but as they start to age, they don't really perform that much better. So you're better off really going in and upgrading SoC, especially if you're a Pro, to get the Pro, the Max or the Ultra SoC, because you can see that the Max, the Pro, and the Ultra are still performing that much better compared to just the regular M1. And if you're doing this professionally, you're putting a lot of images through it, you're going to save time overall. And as I said before, all these are pretty much the same, the M2 Ultra. Interesting enough, in this group, the M2 Max base SoC is performing really well in the 14-inch chassis, and you're going to see this pop up in the other charts as well. When it comes to JPEG, timing are anywhere between 1 to 3 seconds for all these major machines, with the M2 and M1 really just trailing behind there. So these are really some of the things to think about. The M2 Ultra is 6 seconds, M1 Ultra is 7, and all these, like I said, are just a second apart, where they're really not that big of a deal. How about for the panorama? When we take a look at the DNG file, these are 2 seconds apart. This is $500, and the timing between the two Pro SoC are exactly identical. Now, a couple of things that you may point out that, well, this one has more memory and it might really affect the way how this performed by 2 seconds. Possibly, but when I really show you the compilation of all the machines together, it's really quite strange, because this logically, you can read the chart this way. However, when I show you all the other machines in a lineup, it's no longer true, because we have 128, 48, 36, 32, and then we have two 64 gigabytes machine that are not higher in the chart, not higher than this machine. These are things to really consider and think about when you're really configuring these machines, but it's good to know the result. However, there are a lot of variables at play when it comes to these things. The number of NPU cores are going to matter as well. The Ultra has more, the M2 Ultra specifically, and the M3, particularly the NPUs are faster, but not necessarily more between all the other ones. And it's also a combination between the CPU and the memory factor playing in as well. So a lot of interesting variables at play here. This is a JPEG for the panorama. You can see how they're really just spreading apart. And interestingly enough, 48 gigabytes machine is pulling 1 second ahead of the 128 gigabyte M2 Ultra. So a couple things that I will point out right now. If you're using Topaz as the primary software, don't get more memory. But here's the thing. Most of the time, Topaz are going to be the secondary enhancement software, meaning that you're going to primarily edit your pictures in Photoshop, in Camera Raw, or some other program that will utilize all the other system resources. And this is really telling us that you shouldn't be configuring your machine necessarily based on the way how Topaz software is running, but configure your machine based on the way how their primary editing app is running. And you can see that the M1 and also M2, they are really trailing behind when it comes to all these tasks. Now let's take a look at Giga AI. The Aurora, NEF, and JPEG, there is some timing variation, and interestingly enough, I ran this a few times, and the base M3 Pro is really pulling ahead by 1 second or 2 seconds in this regard on the JPEG, ahead of the top spec one. This is something that I have been testing, so I ran a few tests on this, and it's still showing consistent result, and we can see that the M3 is still trailing behind. How about when we just take a look at the raw NEF file of this Aurora compared to the rest of the machine lineup? Interestingly enough, the M2 Ultra still is at the very top, but we can see how the memory inside all these machines are not spreading in a logical sense anymore. The two M3 Max top ones still doing well. M1 Ultra is pretty much just following behind, and the M2 Max base SoC, I mean, that's no slouch either, with only 32 gigabytes of memory. Yes, it's really starting to double the amount of time that it takes to process these files. So this is one of those where if you're going to enlarge a lot of files, definitely something to think about. Getting a machine with a higher spec, not necessarily more memory, because you can see there 48 gigabytes. It's only within 1 second of 128 gigabytes memory. What about the JPEG file? JPEG brought the results a little bit closer, but they're still 1 second apart, and you can see how they all spread in the rest of the lineup there, with 128 coming in second, and amazingly enough, you still see 64 gigabyte taking a few seconds longer than a machine that has less memory. As I said before, with Topaz software, there are multiple factors at play, so it's not really quite just a straight interpretation of having more memory. The program or the app's going to use that and get the most out of it. What about Giga AI for this large panorama file? So this is 3 seconds apart there, and interestingly enough, the M3 Pro base in the 14-inch chassis is performing slightly better. This one not so much in the JPEG, but these are very interesting results that we are observing right now. And interestingly enough, the M3 with the amount of memory there is really performing just fine and is pretty much holding on to the rest of the group fairly well. I would consider this a pretty decent performance just for the M3. But when we start to really add in a result for the other machine in the lineup, interestingly enough, the M1 Ultra did not perform well in this test at all. You can see how the timing is spread between all these machines. The M2 Ultra, thank goodness, is still at the top of the group, but you will see how all these spread. And as I said before, M2 Max base SoC, just trailing behind, not that much longer. And these are the results that you can see right now. M1 is right there. Interestingly enough, the M1 Ultra, there has to be some anomaly, because interestingly enough, the M2 and M3 is running faster, but I didn't run the test numerous times on this particular Max machine. It's just there for reference, so you can see the result there. Here it is with the JPEG file. This is where pretty much the M1 Ultra is supposed to be. So yeah, there's probably anomaly in the other ones, and the M2 Ultra at the very top there. You can see how this all spread. They're only really just a few seconds apart, and you can see how they are really starting to cluster up together between all of these different machines. And it doesn't necessarily mean that having more memory is better for this particular task. And M1 pretty much lagging behind, even though it has the memory. Now let's take a look at Video AI. For this, I am using a 4.5-minute clip that was filmed on a mini DV camera, 480p interlaced. I am de-interlacing this and up-resing it to 4K. The only thing I'm doing in Video Enhanced AI is the enhancement AI and using the Denoise robust algorithm. If I got in and enabled the other AI algorithm altogether, it's going to take that much longer. So what we're going to see is how this is really up-resing, and it's doing a really good job, by the way. But the thing that I want to really see is just the timing between all of these machines. So we're taking a look at some minor time variation between these two machines, and the way how this is spreading apart really makes a lot of sense until you see that the M3 is performing fairly well. Interestingly enough, I have verified the result from both the M3 Pro variations twice, and they're still giving pretty much the same results. So something is really happening there, that these two machines are not performing that well at all. And when I add this result to the rest of the machine in lineup, you're going to see that they are pretty much not dead last, but really quite there and performing very similar to the M1 Max that has all the upgrade components. Interestingly enough, the M2 Ultra is still performing faster even than the M3 Max, the two variations there, but not by much. And you can see that the timing between all of these, even though the machine has way more CPU core, way more GPU core, or in the case of the M2 Ultra, double the amount of NPUs, it's really not enhancing or really speeding up the task that much at all. So when it really comes to this, I would say that the M1's not doing that well anymore. However, if you can still get an M2 machine, I mean, a Mac Mini, just literally get the one with memory in there, at least 16 gigabyte, and just use that machine as a render farm for yourself. That's really not a bad idea at all. Yes, it does take longer, but you can have just one machine dedicated to that specific task that doesn't cost that much money. So those are really things to think about when it comes to video AI. So what are my thoughts about all of this? From the result that you have seen, if you have a previous generation machine, especially the one that has a Suffolk Pro, Max, or Ultra, for the most part, they are still performing just fine when compared to the M3 generation. They may be slightly slower, but they are still clustering up together. If you have the regular M1 or the M2, that may be a reason that you might want to consider upgrading. And if you're looking to get a new machine or upgrading, The first thing that I would tell you to do is not necessarily to look at the result from these Topaz tests, but to really configure your machine based on the primary editing app that you're using. And I would defer you to many of the benchmark that I have done already. For example, if you use Lightroom Classic, pay attention to the way how Lightroom Classic is utilizing the SoC and the memory in the system in combination on the various tasks, and choosing your machine based on that. When it comes to Topaz software, just let it fall where it may. But if you're going to look at the machine that has either the Pro, Max, or Ultra suffix anyway, you're going to get a really great machine. Now, a couple of machines, if you're taking a look at just strictly the M3, there's really two SoCs that I would say are clear winners in this lineup. First would be the M3 Max. That would be the base M3 Max inside the 14 or 16-inch chassis. That's a really great performer that's going to give you a really great bang for the buck. If you're looking for just the 14-inch one and the M3 Pro, I would say the base M3 Pro inside the 14-inch chassis is also an amazing value. But as you have also seen in many of the charts I've shared with you already, for instance, the 14-inch M2 Max base SoC is performing really well. And you can get those at a much better price now. So there are a lot more options now that we are in the third generation of Apple Silicon. Anyway, I hope that this video helps clarify and answer some of the questions you may have about Topaz software, how they are performing with various generation Apple Silicon, and also with the M3 as well. If you have any questions or comment, leave them below, give this a like, subscribe, and hit the bell if you're new, and in art we trust.